right, let's go ahead and get this fired off. Good morning, good afternoon, good evening. Welcome to the Rise Up podcast. I am David Schultz. And today we're going to be continuing our conversation around the unified namespace. And we've been trying to socialize what that message is, but today we're going to be joined by a person that really needs no introduction, Rick Bullota. And we want to talk a little bit about what he has termed as the Uber broker. So without further ado, Rick, please make an introduction for people in the audience who might not be familiar with you.
Happy and good to be with you. I'll give you the express version, but my background's pretty much been all around every facet of manufacturing, whether working in operations, systems integration, engineering support to operations, software companies in the space. So that's kind of the world that I live in from the industrial sector. Started a couple companies in the space, Lighthammer, which became part of SAP. ThingWorx became part of PTC. I've worked at Microsoft. I've worked at Wonderware / Aviva. So I've been in sales, marketing, and technical roles. So it's kind of I think an interesting perspective on what works and doesn't work in this space. As you know, also never one to be short on opinions. So hopefully we'll get to the bottom of what a UNS is today.
Yeah, absolutely. Yeah, and I think it's defining that UNS as well as, what does an Uber broker bring to that equation? Because at some point we talk about there's always going to be nodes within that ecosystem, and those nodes are going to have various capabilities. So where do you move things around? Because at some point we're going to have to do something with the data. We're going to have solutions. Where do we want that to look like? And it's purely going to be a function of the problem that we're trying to solve. There's a lot of different ways to go about skinning the cat. I think what's important to me is this is not your first barbecue with manufacturing data and try to solve, some very large challenges that you have, especially at the time. So you mentioned a couple of products that you've been involved in. The first one's being Lighthammer. Sure. Of course, the second one is what now is ThingWorx or PTC ThingWorx. So let's just start with Lighthammer. And can you tell us a little bit about what went into that product? What was the problem you were trying to solve? And ultimately, it's really get into maybe a little bit of the weeds of some of the design considerations that you made with Lighthammer.
For sure. So let's put a time frame on it. This is 1998-ish that we launched Lighthammer. But I had just finished my second stint at Wonderware, sales and product management. And if you kind of look at what SCADA and HMI systems did at the time, it was abstracting away all the devices, controllers, and things like that to provide a unified visualization plane. You could have some logic in there, event-driven at the time, right? Even most of the SCADA systems were event-driven then. But the problem that we saw was, all right, this is great for abstracting away all the devices, and then you look around in a plant and you've got multiple HMI SCADA systems, historians, SQL databases that people being used for MES, lab applications, quality, ERP, you name it. It's a problem that's as old as manufacturing technology, and it didn't seem like anyone was addressing the need to bring that all together. So the first epiphany, I guess, was the importance of abstraction. If I'm dealing with a stream of time series data coming out of OSI Pi or a bunch of timestamp values coming out of or events coming out of a database or whatever, why should they be different? Why should I, as a consumer, have to deal with those, in a proprietary way? So the first step was the idea of connectors that could talk to these things, provide that data in a unified format. And at the time, it was XML based. And then provide a common API, if you will, to let you query, consume, and interact with that data. And the first goal was something we called Lighthammer Illuminator. So Illuminator was all about visualization. And at the time, if you wanted to see some historian data along with some LIMS data or some other operational data, it was the swivel chair approach, right? You go over to one app and another app. So we I remember one of the first demos, it was a display with data from like 16 different sources on the same web page. Coincidentally, this was about the same time that web technologies were starting to get some traction. So a browser was now an accepted way to interact with your operational data. So we were building, REST APIs and XML stuff. And at the time, the only real option that you had for rich visualization that would run in a lot of different places was Java applets. It sounds so dated now, but it's really all we had then. I joke all the time that one fundamental flaw of the web at that point is you couldn't draw a circle. Like you could do squares and text and everything. So to try and represent data, we needed a kind of a rich and interactive user experience. So we built a bunch of Java applets, a back end that lets you, kind of interact with it through web APIs. And that really got a lot of traction right out of the gate, just for remote visualization, for the ability to see data from multiple sources. And then we kind of had the next light bulb moment was, all right, if we can get this, we already have APIs that our visualization clients are using. The logical next step is to avail other systems of that data. So that's when we started getting into the ERP integration, those kinds of application areas. We built kind of a visual flow chart, almost Node-RED-like, to be honest with you. It was called Execute, drag and drop environment for building, sequential logic, data transformations, all that kind of stuff. And the combination of those two, customers did some absolutely amazing stuff with, integrating into kind of like adaptive planning. Hey, based on energy, based on material availability, energy, and data from our historians, we're going to kind of readjust the schedule. Just some interesting things. We got on the radar map of SAP because some of our largest customers were their largest customers, and in 2005 we became part of SAP, and that became SAP MII, Manufacturing Intelligence and Integration. Interestingly, that product's gonna be sunsetted, I think, about 2 or 3 years. So it's had a good run, but yeah, so that was what Lighthammer, and again, the big takeaways were unified access, consistent data representation, web APIs, and extensibility. So you had toolkits, you could build your own connectors, and that was the approach that we went for.
Yeah, that's amazing, because it sounds like the problem that you were trying to solve in 1998 it continues to be a problem that we're trying to solve now. Maybe the names are a little bit different, but there still continues to be that. So it's just perfect for what it is that we're trying to do. Is that the challenge is still there. How do we do that using a modern architecture? Because certainly from mid 2000s to now, the technology is just, it's been revolutionary, and it just continues. So.
One other comment, Dave, is I think the other reality that we had there was when you have data distributed in lots of different systems, sometimes it's not acceptable or even optimal to bring it all into something like a data lake or a common database. Mm-hmm. So the other light bulb moment was I look at a lot of dashboard solutions, and that's they're very one way, right? Dashboards are typically also, it tends to be very difficult to drill down between data sources. That's something we found customers doing some super interesting stuff around quality. We have these events occur over here. I want to see context from what was running at the time, what materials I was using, and the process conditions at that time. That was extremely hard to do at that time with the tools we had for visualization. So the idea of the user experience being much more interactive, being able to drill down across data sources, that was another kind of, I think, key capability that came out of that.
Yeah, this just to me is what's amazing about how ahead of its time Lighthammer happened to be. And there just seems to be a lot of great. It's almost like what is old is new again, and it seems like, oh wow, this is amazing. Look at what we can do. And it's like, yeah, we were actually doing that a long time ago. The technologies were a little bit different, and maybe it was a little bit, we'll just say kludgy at that time, but it still persists. So I always just fascinated by it's the classic. It's just like fashion. What's old is new again. But there it is. So
cool.
Yeah, so within digital transformation, a lot of the work that I do is we're now trying to connect to all these different disparate assets out there, and it's certainly what Lighthammer was doing, is connecting all these different data sources. But now we're trying to get more into the machines, and that's where a lot of my time is focused on. How do we get data out of these things? Mm-hmm. And my understanding of ThingWorx was designed to do something similar. But can you just talk a little bit about ThingWorx now, and just, again, same type of thing of why was it created, what was the problem that it was trying to solve, and then ultimately, how is it used, and some of maybe the highlights or key takeaway moments from that experience.
Sure. The big difference, obviously, a fast forward of over, this is 5 years, really 10 years from when the Lighthammer products were first started in technology. So we had a kind of a clean sheet of paper, some better technologies to work with. But that's actually secondary to at the time this whole buzzword Internet of Things was starting to get a lot of buzz. You had companies like Cisco, IBM, everybody advertising on national TV of the Super Bowl, right? About smarter planet and Internet of everything and so on. Reality was most of those companies weren't actually doing much or delivering much product. So they did a lot of great marketing pull for what's possible in connected products, connected services, connected spaces. And I had done some research work at SAP on that. We call real world awareness. What happens when you connect the physical world to, manufacturing, public safety, retail, healthcare, a little bit of everything. And once again, the takeaway was it's just too hard. Everything was a custom one-off. So we perhaps had a bit too ambitious of a goal to try and build a platform. And so I actually tried to get that going within SAP. It was just timing wise, it wasn't going to happen. So we kind of tried to serve two masters: this Internet of Things, a connected fleet of very homogeneous devices, typically your electric meters or your blood analyzers or whatever, but you're also managing those devices remotely. And then the industrial IoT use case, which is more the bread and butter that we knew from the Lighthammer days. And in hindsight, we probably should have forked that at some point and had two variants of that. 80-90% of the code would have been the same. But nevertheless, that was kind of the goal, was to serve those two communities. I learned along the way, and through acquiring a company called Palantir Systems, not Palantir, different company. I learned a lot about what shortcomings we had in ThingWorx around things like device management, device provisioning for that IoT use case. Mm-hmm. And then we also built a much, much richer user experience at the time, better development environment, better visualization tools, and kind of luck, whatever timing. We said, well, we're gonna need a scripting language we've already abstracted away all the data. We already have a rich twin. It brought a twin model, a kind of concept of types of things and instances of those things. And then we said, well, there's a new generation of folks coming into this world that something like JavaScript and HTML is very natural and native to them. So we built our scripting engine for that around JavaScript and exposed all the twin models and all that stuff into it. I think that was a big kind of rocket fuel for the adoption of it, both in the IIoT side and the general IoT side. And we were, once again, it's this whole concept that you want to normalize, abstract away data. I think the big stretch from the Lighthammer thing was introducing these digital twin models. More than just data. They had data, events, they had services that they could expose. It was actually a very sophisticated object model, graph database under the hood to let you model the relationships between things. Integrated search was kind of a novel capability at the time. At the time, it was inherently event-driven because you would attach scripts to events just like you do in any kind of web stuff. It actually did have an external pub sub at that point. It's kind of since been taken out of the product. And I think another thing that customers found more so in the IIoT space was that it provided a common place for access control, right? If you've got these 20 different systems, it gave you a kind of control plane for accessing those systems in a relatively secure way. who's allowed to get at what information, particularly when it starts to now stretch beyond just people in your company. Your customers want to see some quality data. Your machine providers want to manage or optimize performance of their filling machines or whatever. So we put a lot of time into that aspect of it as well. And we also learned that things that are easy in a prototype, you need to rethink them dramatically if you're going to deploy them at scale. At scale being thousands, tens of thousands, millions of stuff. Everything changes. The user experience, how you do stuff, the technical approaches. So it was a really good learning exercise for a lot of those issues as well. But that was I think the big takeaway was trying to serve those two different distinct markets, bringing a coherent object model, twin model into what we call it a thing model. And also considering the implications of both scale and distributed systems.
Yeah, I mean, so when I first took a look at ThingWorx, this would have been, 2016, 2017. A lot of the information that I was finding, it was more of an IoT platform than an IIoT platform. And what I mean by that, it was, smart cities were pretty prominent at that time. And that's where I at least saw or observed, ThingWorx being used more. But, certainly there's been some acquisitions and some relationships there that I'm seeing more ThingWorx deployments within what I would call an IIoT, so within that industrial space. But I would still characterize ThingWorx as an IIoT platform, and the intent is that we're connecting to disparate systems, we're bringing in the context, providing the visualization, and I guess my second thought on it is it's very powerful and it does a lot of amazing things, but that also tends to make it a little complex. That said, you can solve some amazing problems with it.
And in retrospect, introduced too many weird terms, right? Thing shapes and thing templates and thing, for anyone that's been a programmer, the concepts were very natural, right? It was, types and classes, but there was a steep learning curve to get up. But once you got it, it really, in my opinion, it was just incredibly powerful twin model that you could program against, both event-driven, externally through APIs. Another thing that both, I think, Lighthammer and ThingWorx helped me emphasize, and when we talk Uber broker, when I talk to any vendors doing anything, I always emphasize the importance of extensibility. You think how everything your customers need, and that's absolutely, of course, wrong. So thinking about how can you let your customers or your integration partners or your VAR partners or OEMs add their own connectors, logic, visualizations. So a lot of, when I look at product architectures and approaches, always an emphasis on open APIs for everything, open APIs to anything you can do from the configuration environment, you should be able to do through an API. And then APIs to get at the data and functionality, and then extensibility for what you can talk to and how you can visualize that. It's just, to me, that's a must-have for any platform.
Yeah, absolutely. I tell people that, I can solve a problem, but can I scale that solution? Right. And more importantly, can I extend that solution? And, to me, this is a perfect segue into just talking about the concept of the unified namespace, because that's the problem or the challenge that it tries to solve, is having a mechanism to where we can both scale and extend what it is we're trying to do. So it's, as I mentioned, before we got going on the call, we're trying to socialize the definition of a unified namespace. And what we're using, it's an approach to an event-driven architecture that uses a pub/sub technology, that uses semantic data models, and those are published or subscribed through a defined topic namespace. And while that sounds very nebulous at the get-go, yes, it is, because it's more of a concept, an idea, it's an approach, not as much an architecture. But at some point, you will build in this unified namespace architecture, using tools like ThingWorx or HighByte or Ignition, or there's several others. That list certainly wasn't exhaustive. Sure. So just from that standpoint of the definition that I've just proffered up, is that it's an approach how do you, when you're in conversations, how do you define the unified namespace?
Perhaps first of all, let's give Walker and his team an enormous amount of credit for bringing this to the forefront. It's now a word that's, when you have the analysts using it, the bigger analysts, there's some traction, right?
Absolutely.
So for me, it's a concept that it was natural. I just kind of like, of course, that's how you do stuff, because that's kind of how I approached the importance of discovery, right? The ability to, what good is a easy access to information if you can't find out what information you have to access? Mm-hmm. I think perhaps the expansive view that I have is the accepted view. I think a lot of people right now is it's kind of the current state of the business, right? That it's a snapshot of the now. I personally think that if you have that model, not every, but many of those same topics, data points, events also have a historical exhaust. I think it should be the common consumption layer for both current and historical. I do think it's not just a unified namespace for the data, it's also the unified namespace for the metadata. And then the other unified aspect to me that's very important is I should be able to know that each of those nodes and topics in that namespace have a consistent data format. Yes, it's fine if you have a bunch of weird data formats, you can live with that, but it's a lot of work. It's a lot of unnecessary translation effort. I think we have to get where the other U is a unified data format, unified APIs to consume that beyond PubSub, and then unified access controls. I know that's a bit of a stretch, but I had it was a discussion thread on LinkedIn the other day. We were talking about, how can standards help with that? And kind of my vibe was that standards are helping a bit, but they're also some companies and users are using the standard as a bounding box, not a starting point. And to me, it should be the other way around.
Yeah, absolutely.
Standards give us this common set of interoperability we can build upon rather than it limiting our functionality. So that's when we get to the Uber broker discussion, that's kind of the idea that let's go beyond, what the foundational UNS definition is.
Yeah, so just, I'm not familiar with the conversation you're referring to, but my experience has been that the standards are often, they're misunderstood, or there's a lack of understanding of what actually it's saying in there. And we get pigeonholed into this idea of, well, no, according to that standard, we have to do this. And standard actually doesn't say something like that. So, ISA 95 is one of them that I think is very misunderstood by practitioners within the market. But that's a topic for another time.
I think it's an important point because how that gets communicated to the end user base and the systems integrators and the implementers is pretty important, right? I mean, I've been involved in both S88 and S95 as a committee member. And we used to introduce what we call weasel words. And weasel words were, if you couldn't get everybody to agree on something, you do shall instead of must, or, and you leave open, or you leave enough flexibility that kills interoperability. But anyway, it is important because we just have to set the expectation with the customer community that it's not magic, right? You just can't, it helps. Think of them as best practices. That's kind of the way I do it. Yeah, but it doesn't just work.
Right. Yeah. To me, it's take what works and leave the rest. So if there's something that it just doesn't fit, don't die on the hill of no, we have to conform to it. That's the whole piece of do what makes sense. There's always going to be a unique way you're going about doing things. And so, like I said, don't die on that hill. So
don't stop at the border of the standard. Right.
Right. Yeah.
Press on.
Exactly. Yeah. Absolutely. Yeah. Totally agree with that. So, going back to this UNS, we've talked about this PubSub, and one of the most common brokering technologies or transport, the application layer is MQTT, and of course its companion Sparkplug B. So, for you, I know you've been critical around the MQTT and Sparkplug. I think it would be important just from a PubSub a part of the UNS, just to talk a little bit about that. So,
Sure.
tell us more about some of the MQTT Sparkplug B concerns that you have.
Yeah, and let's preface it with I use MQTT on a daily basis. Like my lab is all connected up through MQTT, so I'm a fan. What Arlen and Andy and the team implemented is fantastic. I think where things fall apart is when we try and make a technology do things that it really wasn't intended to do. So the biggest, first of all, at its core, it's an extremely powerful way to implement a pub sub environment. There are others, of course. There's AMQP and many others, but for our domain, what's the T? Telemetry, right? It was it's designed for this kind of data connectivity. I think where something got lost is in terms of the way we applied it to UNS is number one is discoverability. I think that's probably the single biggest problem right now. There just is no intrinsic way to connect to a broker and say, what's your topic structure? So that needs to live somewhere else. You need some other API, some other connection. So to me, that's kind of the foundational piece. There's no kind of, and we'll talk about Sparkplug in a second. They're opaque payloads, right? There's no accepted representation of data in there. So there's been efforts to try and, whether it's OPC-UA over MQTT, Sparkplug, generic JSON, countless others. That's a problem that needs to be solved. So we need to be able to discover it, find out what its formats are going to be. We need to be able to decorate those with metadata. Like just a topic name is like a tag name in a SCADA system. It can only tell you so much, right? Why can't we have description, range, entity type? So today we've got things in the MQTT protocol that let us send extra stuff along with messages, but there's no place to easily persist that without topic bloat and all that kind of stuff. So I'd personally love to see the ability to add metadata to MQTT topics, durable, as well as APIs to let you query the topic namespace. So those are and there's some efficiency stuff. There's things that could be done better in terms of that Sparkplug tried to address, where you can publish multiple values in a single message. I'd love to see the MQTT committee consider that capability. But for the most part, it's good at what it does. I think we're trying to push it a bit too far. And then the question becomes, where does that go? We'll talk about that in the Uber broker idea. On the Sparkplug side, again, a very well-intended effort focused initially on kind of the SCADA to device integration and solving that problem, being efficient in how we move data back and forth, binary formats that are very compressed and efficient, being able to publish metadata, interrogate metadata, which is super powerful. Somewhere along the way, again, I think there are improvements to the implementation that could have been done, that need to be done. So I'm trying to provide as much input as I can into that. And I encourage the user community to let their needs be known as well. The team that's working on defining the next gen Sparkplug is very receptive. They're great people. It's we just need to kind of have an open dialogue about what are the most important things that will bring the most value to the collective community. Things like my two big ones there. I think we have to get to a point where JSON is an accepted format for Sparkplug. And then going back to kind of the ThingWorx thing learnings, the idea that services or commands or functions or methods, whatever we're going to call them, are another thing that needs to live in a unified namespace. So as an example, a service that can let me query my history for a machine or run a calibration sequence and get some results back. There's some minimalist capabilities there in commands in Sparkplug, but I believe we need to both build that out to support request response, fully typed with metadata. And I think there's a lot of value at the MQTT level or above it. Let's solve the problem, whether it's over MQTT or sideband or something like that, to support a request response mechanism as well. That's kind of the jihad that I've been on lately for those two things. And there's a lot of other little smaller details I will say again, the Sparkplug team has been super receptive, and I think just a couple little things to kind of push it over the, a couple other features, if they can make it into the next gen of Sparkplug, will be extremely helpful. There was one, the metadata discovery, efficiency of that, how that kind of birth process worked. That there's great work being done to advance that. So overall, I'm skeptically optimistic, I guess is the word I'd use. MQTT moves at a different pace, right? It's kind of a more traditional standards body. I don't think there's enough end user involvement in that, or end user, it doesn't appear to be, at least, feedback going into that team. But I also think that it doesn't need to happen at that layer, right? We can solve those problems at a layer above MQTT. And this is where, the idea of don't constrain it to what the standard does. Let's build standardized layers or standardized broker capabilities that vendors can implement that basically backfill those deficiencies. I think there's a very real opportunity to do that, and fairly easily.
Yeah, absolutely. And I think we have, I've been working with Sparkplug for 4 or 5 years now, and I really, contain it, if you will, within the overall architectures, that it's very good for plant floor data. I mean, you take a look at the companies that are supporting it. It came out of inductive automation in their Ignition, or Canary, or trying to think of some of the other main sources that use the Sparkplug. It's really good for telemetry data, SCADA data, because it does what I would say some very SCADA related type activities. You're grouping your node IDs to ensure that you're not crossing over with that. But as you get into larger areas, flat MQTT, or what we refer to as flat MQTT, tends to work better. So that's where I am. I mean, we're just trying to get data to move around.
And a great example there is another, I think, critical feature. I hope it gets in there. Sparkplug is very opaque, right? You've got a bunch of metrics, could be 1 to n, and could be very big. But if I'm interested in subscribing to a machine stoppage, or a temperature alert, or just the the speed of the machine, I just can't do that today. And to me, that's a fundamental flaw. Very easily addressed with a standardized approach that a Sparkplug compliant broker should optionally, and it can be optional, support metric expansion, where it takes those in, blows them out into a some pattern-based namespace. I contributed a code to HiveMQ as an extension to do it for that. It's very doable. Maybe that's the source of my frustration overall.
Sure.
I have a short trigger, but I just know these things are so doable. That's the frustration. They're so doable, and let's just get it done.
Yeah, my observation around this has been, certainly we could build it into the standard, but at what point should it be something that's unique to, say, HiveMQ or EMQX, or even the Cirrus Link? They have their Chariot SCADA, their broker. Sure. That it's more of a feature that's not specific to the standard. It's something that we do to expose some of this information. And I think, a lot of what started this whole UNS conversation is the first question that people almost invariably ask is, well, where do I store my data? How do I access, certain, historical data that's in there? And I always said, well, maybe that's just a function of the broker, or the function of something that's there, which, we're getting very close to. Let's fire off the Uber broker conversation, but I don't know if there's any final comments you had on the whole MQTT before we get there.
Sure. I mean, if you look at, Litmus now has an MQTT, NAT, NAT's, HiByte has an event. That's table stakes now, right? I mean, that's kind of like, it's what we do with it, and what we do around it. To your point, there are all these companies doing some very innovative things around that. It would be great if kind of the APIs, or the approach, or the data formats we could agree on, so there's interoperability at those levels. If it doesn't happen, that's opportunity lost. But let's deliver customer value. Let's deliver the stuff people need.
Absolutely. Yeah. And I think as we've talked about the Uber broker, it gets to some of the issues of, we want to have a common endpoint. And it's not just, the UNS is not just this broker, it's an event driven architecture. So there's going to be other things that are there. But if we just think of it purely as an MQTT broker that's 311 and 50 compliant, and it supports Sparkplug, the UNS is more than that. But conventional brokering technology, it's limited to some of the things that you're going to need to do. And it sounds like that's what the Uber broker is designed to solve. So,
Yep.
with that, let's just get right into it. What's the Uber broker? I think we have a good understanding of what started the whole, what's the problem we're trying to solve, but maybe just level set of here's the problem I saw and here's how I'd go about fixing it.
Yeah, I think and let's step up even one level. It's this the what do the Venn diagrams look like on what's a UNS, what's an IIoT platform, what's an Uber broker, an Uber broker is just a term I came up with and I did it specifically to say, let's build on top of the brokers. Let's not throw away the broker as a key piece of that. And quite frankly, it offers the opportunity for a new generation of players to become IoT platforms. But yeah, that was just, and for me, sometimes it's easier to speak in code. Like it's easier for me to build a working prototype and kind of show the concepts. So that's what I did. I whipped up something that was, it intercepted any MQTT messages, Sparkplug messages, expanded them. You could automatically historize any stuff into a time series database. It provided a query API for the topics and their metadata. It provided a query mechanism for the historical data from each of those values. And it's not intended to be production level or even a product. It's an approach that helps me communicate ideas, basically. And ultimately, I would love to see the broker vendors, take or anybody that wants to build kind of a next generation IoT companies like Rhize, I don't care how it's done. It's just functionally, these are kind of the capabilities that these platforms need. So yeah, that's really the genesis is what other capabilities can we deliver to address the shortcomings we talked about, just generically in IoT platforms, in pub sub architectures, and kind of the things we've referred to as a UNS.
Yeah, so as we do our, what's the hub of our system is, we use NATS for that, and it does have the ability to use MQTT, but we also expose an API. So I know we've talked a lot about we need to have access to, say, some functions or methods so that, there's certain things that I can do to access that data. But, the UNS is the current state. So there's a broker that's now going to be moving around. It's that pub sub for just that transport mechanism. And also having this API that has these functions, that has methods, that has the queryability of some, what is referred to as the warm data and the cold data, that I can start retrieving things back. But when you build that into a full UNS, it's that there's also a standard, say, ontology of that's what the data is going to look like. If I query this, I'm always going to get this type of information back.
Well, and a mantra I've always had, my teammates at both companies will confirm, is make the easy stuff easy and the hard stuff possible, right? So why should I have to write, if I want to historize as new values come in, why should I have to write a script for that? That's insane. That should just be a check a box, right? A declarative part of your object models and twin model. Just make it easy. So a lot of what I've tried to do in those prototypes is exactly that. Just make it declarative, not code, right? To accomplish the simple stuff, but give you the headroom to do pretty much whatever you want. And yeah, and that Uber broker, if you got a REST API for publish, a REST API for reading most recent values, all the historical values, all that kind of stuff. And another, I think, debate is what topic, what should topic namespaces look like? Certainly, for a lot of folks, an ISA 95 based approach makes sense. For others, other models make sense. And I'm a believer that, use and not or, right? That if you think of this is really geeking out, but think of like a Unix file system. You have symlinks, right? I can have the same file in multiple places. It's one file, it's one piece of data. Why can't we have that too? Why can't I have a hierarchy, that namespace that fits well for my maintenance team, another one that's for operations, another one that's for the quality folks, that either reshapes, reduces, whatever, who cares? But, we should be flexible in that as well.
Yeah, I like Symlinks in Linux because it makes I make fewer typing mistakes, because sometimes you'll have these files that are like, wow, somebody must have gotten paid by the number of characters in this, so we'll just create a little Symlink and and now I can get at it. It's for dummies like me to be able to do certain things with it. Yeah, so God, there's one other question that I wanted to ask you in here, and all of a sudden I'm at a loss for it. So let's just go ahead and wrap it up. So just in any final thoughts? We've talked about a lot. It seems like going all the way back to the beginning of ThingWorx is that we're still trying to solve a lot of the same types of problems in there. It's just creating this semantic data, being able to easily access data through this structure that's in there. But going forward, what do you foresee on the horizon? Is we're really getting rich into this industry 4.0, and companies going through digital transformation.
Sure.
Where do you see this finally landing, or what do you think is going to be? Yeah, we finally landed, we've gelled, we've emerged. Any ideas on what that might look like?
If I knew, I'd be all my investments would have done well. But I don't know. I guess on the positive side, every indication, although there's the border skirmishes, every indication is that everyone wants to get to approximately the same place, which is super encouraging, right?
Agreed.
I just hope the customers don't get stuck in the middle of lack of progress and just standards. By the way, can be the most awful outcome for customers, because sometimes you end up with lowest common denominator, which is lowest, right?
Yeah.
And
yeah, absolutely.
And the other thing is things take a while to be realized, and in the 3 to 5 years that a slow moving group can get something done, the underlying requirements have changed dramatically. The technologies at our disposal have changed dramatically. So I'm naturally like the ADHD poster child. Let's go fast. And so I would say that's my hope, call to action for everybody in the community is let's move things forward, right? I kind of feel like we've been spinning in circles for a while. And ultimately, the number one voice is the end user. The people that write checks have the ultimate voice, right? Other things I do see, and I'm excited to see this, a new generation of folks coming into industrial technology and into manufacturing that have a bit more of a DIY comfort, right? They're comfort with a new set of technologies and tools. That's cautionary tale. We also kind of need to be thoughtful about, just like we said, what's old is new again. The amount of reinventing the wheel that happens every single day is just mind-boggling to me. So let's use well-established stuff for the stuff. I think I mentioned this in the Industry 4.0 Discord. Jeffrey Moore, the Crossing the Chasm stuff, he has this concept called core and context. And it's like, what's how your company processes a purchase order is not a strategic advantage versus how someone else's does. But the way you manage your supply chain may very well be. So just generically, that concept is the stuff that's generic, let's have that built into the platforms, right? Let vendors innovate around that, and then let customers, integrators, and OEMs really go nuts around that. And we have a generation, I think, of folks that are coming into the space. We need to recruit them into the space that are really well equipped to do that kind of stuff.
Yeah, wholeheartedly agree. So with that, Rick, thank you so much for your time. Always great talking with you, because a lot of the things that I think about, there's challenges here. I don't want to reinvent the wheel. What have you looked at before? And always the guidance and impact is very much appreciated. So thank you for spending some time with us here today. And with that, thank you, everybody. And we'll see you on the next episode of Rise Up. Talk to you soon.